Let us discuss complex numbers and demonstrate concept session. Complex number is defined like this. If A and B are any two real numbers, if A and B are any two real numbers, then A plus IB, where I is equal to root of minus 1, is defined as a complex number. Why complex numbers are introduced means in real number system, square root of negative numbers is not defined. For example, root minus 4 is not a real number. So in real number system, there is no definition for root of negative numbers. That's why a new number system is introduced, which is known as complex number system, where root of minus 1 is taken as I. I is known as imaginary unit. And in case of complex numbers, root of negative numbers are different like this. Root of minus 4 can be written as root 4 into root minus 1. Root 4 is 2, root of minus 1 is I. So what is root minus 4 in complex numbers? 2. So to define square root of negative numbers, a new number system is introduced, which is known as complex number system. And the definition of complex numbers is like this. If A and B are any two real numbers, then A plus IB is defined as a complex number, which is usually represented by the letter Z. In Z is equal to A plus IB, A is known as real part of the complex number, B is known as imaginary part of the complex number. Real part of Z is denoted like this, RE of Z. RE of Z means real part of Z, which is A. IM of Z, imaginary part of Z is B. RE of Z means real part of Z, IM of Z means imaginary part of Z. A complex number is said to be purely real if imaginary part is 0, that is if B is 0. And it is said to be purely imaginary if real part is 0, that is A is 0. Okay, purely real means imaginary part 0, purely imaginary means real part is 0. Next, what is conjugate of a complex number? If Z is equal to A plus IB is a complex number, then its conjugate is denoted by Z bar and it is given by A minus IB. If Z is equal to A plus IB, then its conjugate is A minus IB, which means real part should be same and sign of imaginary part changes. Here in Z is equal to A plus IB, imaginary part is B, here imaginary part is minus B. So how to get a conjugate of a complex number means take real part as it is and change the sign of imaginary part. Then what is conjugate of Z bar? What is conjugate of A minus IB? Again you get A plus IB, which is nothing but Z. So Z bar whole conjugate is nothing but Z. Then what is Z plus Z bar? If you add Z and Z bar, you get 2A. A is nothing but real part of Z. So Z plus Z bar is always 2 times real part of Z. What is Z minus Z bar? You will get I into 2B or 2I into B. B is nothing but imaginary part of Z. So Z plus Z bar is 2 times real part of Z. Z minus Z bar is 2I times imaginary part of Z. Then what is Z into Z bar? A plus IB into A minus IB. This is nothing but A square minus I square B square. We know that I is equal to root of minus 1, so I square will be minus 1. Then this becomes A square plus B square, which can be written as modulus is not okay. So Z into Z bar is A square plus B square, which is always a real number. Next, if Z is purely real, when we say that Z is purely real, when you don't have any imaginary part, B is 0. If Z is A, what will be Z bar? That is also A. Then what is Z minus Z bar? 0. So Z minus Z bar will be always 0. If Z is purely real, that is a condition. Okay, so what is geometrical representation of a complex number? Any complex number can be represented as a point as we do in geometry. Z is equal to a plus ib or x plus iy can be represented as a point x comma y in a plane known as complex plane or organ plane. So what is a complex plane or organ plane? It is a plane in which the complex numbers are represented as a point. In geometry, usually we have x-axis and y-axis. Here we call that x-axis as real axis and y-axis as imaginary axis. And this is the origin. And x plus iy, as I said, can be represented as a point x comma y. This distance is x and this distance is y. And the distance of that point from origin, which is nothing but under root x square plus y square, is known as its modulus denoted with mod. So what is the definition of modulus of a complex number? It is the distance from origin to the point P which represents a given complex number. So if z is equal to x plus iy, then its modulus z is represented like this, which is given as under root x square plus y square. So the length OP is known as modulus of the complex number. And if theta is the angle made by the line OP with real axis in positive direction is anti-clockwise direction, then that theta is known as argument or amplitude of the complex number. So what is the amplitude or argument? It is the angle made by the line OP with real axis in anti-clockwise direction. So from the diagram, it is very clear that tan theta is equal to opposite side. This is y, this is x by adjacent. So what is theta from this? Tan inverse of y by x. So argument theta is given as tan inverse y by x, and modulus is known as under root x square plus y square. Okay. This is modulus and amplitude of a given complex number. Now, as just now we discussed, z is nothing but x plus iy. This is origin. This is p. This is x comma y. This is theta. This is y. This is x. From the diagram, what will be cos theta? This is modulus, which is also represented by r. Cos theta is nothing but x by r. And from the diagram, sin theta is nothing but y by r. And we know that z is equal to x plus iy. X is nothing but r cos theta plus I into y is nothing but r sin theta. Now take r common. You get cos theta plus I sin. So any complex number z is equal to x plus iy can be written in the form of r into cos theta plus I sin theta. This form of representing a complex number is known as mod amplitude form or polar form. Here r is known as modulus, theta is known as amplitude. That's why this form is known as mod amplitude form. This cos theta plus I sin theta can also be written in short form as cis theta. So r cis theta is known as mod amplitude form because r is modulus, theta is amplitude. So remember, any complex number x plus iy can be written in the form of r into cos theta plus I sin theta. In short, it is written as r cis theta. That form is known as mod amplitude form. Theta is known as amplitude, r is known as modulus. And what is Euler's formula? E power ix is equal to, look at this, e power ix is equal to cos x plus I sin x is known as Euler's formula. Then what will be e power minus ix? cos x minus I sin x. Replace I with minus I. When you add these two, you will get 2 cos x. So what is 2 cos x? E power ix plus e power minus x. So what is cos x? E power x plus e power minus x by 2. When you subtract these two, you will get 2i sin x from the right sin x. These two are known as Euler's identities. Okay. Now, what is exponential representation? As I said, z can be written in the form of what? R cis theta. And what is that cis theta? R into cos theta plus I sin theta. And that cos theta plus I sin theta can be written in Euler's form as e power I theta. So z is equal to R into this is e power I theta. Just replace cos theta plus I sin theta with e power I theta from Euler's formula. So z can be written as R into e power I theta, which is known as exponential representation or exponential form of the complex number. Next, what are the properties of modulus of the complex number? Modulus of z is always a non-negative number. Non-negative means it can be either 0 or positive. So mod z is always greater than or equal to 0. And mod z already we told you, root of x square plus y square. If z is equal to x plus I. So this modulus z is always greater than or equal to x, which is real part. It is always greater than or equal to imaginary part also. And modulus of z, what is z bar? X minus I. Then what is mod z bar? Modulus means under root real part whole square plus imaginary part whole square, that is minus y whole square. Even though we have minus, whole square becomes 4. So mod z bar, mod minus z bar, all are one and the same. And what is z into z bar? Already we told you z into z bar is nothing but x square plus y square. This is nothing but mod z whole square because mod z is under root x square plus y square. So z into z bar is mod z whole square. Next, these are the properties. Mod of z1 z2 is equal to mod z1 into mod z2. Mod of z1 by z2 is equal to mod z1 by mod z2 under the condition z2 should not be 0 because it is in denominator. Next, mod of z power n, mod z whole power n. And these are the formula that have to be remembered. Mod of z1 plus z2 whole square and mod of z1 minus z2 whole square. So all these identities you need to remember. Okay. Next, what are the properties of amplitude? Till now we discussed properties of modulus. These are properties of amplitude. Amplitude of z1 into z2. Amplitude z1 plus amplitude z2 plus 2k pi, where k is an integer because we know that 2n pi plus theta is same as theta if n is any integer. Similarly, amplitude of z1 by z2, amplitude z1 minus amplitude z2 plus 2n pi, where k is an integer. Next, amplitude of z power n is n times amplitude of z plus 2k pi. And logarithm of a complex number. This is important. This is e power I theta. And already we know that z can be written as r into e power I theta. So log of m into n, log m plus log e power I theta is I theta. That is log of its modulus because r is nothing but modulus plus I into theta is nothing but amplitude. So remember, log z is nothing but log of its modulus plus I into its amplitude. So what is De Moivre's theorem? If n is any integer, cos theta plus I sin theta whole power n is nothing but cos n theta plus I sin n. This can be written in short form as cis theta whole power n is equal to cis n theta. This is what is meant by De Moivre's theorem. Similarly, cos theta minus I sin theta whole power n is cos n theta minus I sin n theta cis minus theta whole power n is equal to cis of minus n. So if n is an integer, cos theta plus I sin theta whole power n will have only one value, cos n theta plus I sin theta. But if n is a rational number, if n is a rational number, then cos n theta plus I sin n theta is one of the values of cos theta plus I sin theta whole power n, which means if n is an integer, it will have only one value, which is cos n theta plus I sin n theta. If n is a rational number, cos theta plus I sin theta whole power n will have so many values, out of which this is one of the values. This is only one of the values of them. Okay. This is the n. Next, what are cube roots of unity? Cube roots of unity are given by 1 omega omega square, where omega is minus 1 plus I root 3 by 2, and omega square is minus 1 minus I root 3 by 2. And sum of cube roots of unity is 0. Product of cube roots of unity will be 1. That is 1 into omega square means omega. Since omega cube is 1, omega power any multiple of 3 will be 1. Omega power 6, omega power 9, omega power 12, everything will be 1. Next, remember these identities. A square plus b square plus c square minus ab minus bc minus ca is nothing but product of these two factors. A plus b omega plus c omega square and a plus b omega square plus c omega. And these are the factors for a cube plus b cube and a cube minus b cube. Then what are the roots of x square plus x plus 1 is equal to 0, or omega and omega square, because these values satisfy that condition. So remember, whenever you come across the quadratic equation x square plus x plus 1 0, remember the roots of omega and omega square. Next, square root of a complex number. Remember the square root of a complex number formula like this: under root a plus ib is plus or minus root of mod z plus a by 2 plus I into root of mod z minus a by 2, where mod z is under root a square plus b square. This is for b greater than 0, when imaginary part is greater than 0. When imaginary part is less than 0, instead of plus you get minus. So this is the formula for square root of a complex number. Next, rotation theorem. About a z naught, if this line is rotated, if the line AB, which is joining the points z0 and z1, is rotated by an angle theta in anti-clockwise direction, and let the new position of B is C now, which represents Z2, then theta should be measured in anti-clockwise direction. Then Z2 minus Z0 by mod of Z2 minus Z0 is equal to Z1 minus Z0 by mod of Z1 minus Z0 into e power I theta. This is known as concept of rotation. And these are the some of the results that are to be remembered. If Z1, Z2, Z3 represents vertices of equilateral triangle, out of which these two are very important. If Z1, Z2, Z3 represents vertices of an equilateral triangle, then Z1 square plus Z2 square plus Z3 square is equal to Z1, Z2 plus Z2, Z3 plus Z3, Z1. Or 1 by Z1 minus Z2 plus 1 by Z2 minus Z3 plus 1 by Z3 minus Z1 is equal to 0. And remember this area of a triangle formed by those three vertices.